Hey guys, today we are going to review what we've done with right triangles. And it's kind of split into three different topics, so we'll do it in three different videos. So the first one is going to be Pythagorean Theorem, then we'll do special right triangles, and then right triangle trigonometry. So here we want to find the unknown side length, and something that's very tempting is to think of this as a 45-45-90 or this as a 30-60-90. But I don't have any angle measures that indicate that other than the 90-degree angle. So I cannot use 1 root 2 or 1 2 root 3. Only if there's a 30 or a 60 or a 45 or some tick marks that say this is isosceles. So we're going to use the Pythagorean Theorem. The two legs are the square root of 7 and x. So that's x squared plus the square root of 7 squared equals the square root of 19 squared. Okay, so that's x squared plus, and then the square root of 7 squared is 7. And the square root of 19 squared is 19. So I can subtract 7, and I get x squared equals 12. So that means that x is the square root of 12. We do the square root to cancel out that squared. Okay, now 12 is not a square number, but this can be simplified. 12 is 4 times 3, and 4 is 2 times 2, so there's a pair of 2's that I can take outside of the radical. So x is 2, and then there's a 3 left over times the square root of 3. Okay, next I've got 12 and x as my legs, so that's 12 squared plus x squared equals 13 squared. Okay, so I'm going to subtract 12 squared from both sides, so I'll show you how to do this as a shortcut here without actually doing the squaring. So I've got 13 squared minus 12 squared, and that is 25, and what that really means is 169 minus 144, which is 25. So I have x squared equals 25, and when I take the square root of 25 is 5. So there's my final answer, x equals 5. And then this time my legs are 6 and 5, so 6 squared plus 5 squared equals x squared. So that's 36 plus 25, or I can just type in 6 squared plus 5 squared, and that is 61. Okay, so I do the square root of both sides, so I get x equals the square root of 61. So now let's see if that can be broken down. So 61 divided by, I know 1 goes in, but 2's not going to go in because it's not even. It won't be divisible by 3, I don't think, so that's not going to work. It's not even, so 4 won't go in. I know 5 or 6 won't go in. How about 61 divided by 7? No. 8's not going to work. How about 61 divided by 9? No. And now I see that what I divided by, I got an answer that was even smaller than what I divided by, which means I've gotten to the point where nothing is going to work. So that means that this is the simplest radical form. Okay, find the height of this triangle, which would be important as a step in finding the area, even though we're not asked for the area. So we're going to find the height here. And since this is isosceles, which I know because these are the same, that means that these are going to be the same. So this right here is 24. So my legs here are h and 24. H squared plus 24 squared equals the hypotenuse 34 squared. Okay, so since these are on opposite sides of equals, I will subtract 24 squared. So 34 squared minus 24 squared is 580. Okay, now 580 is not a square number, so when I do the square root, I'll do a factor tree. So 580 is, let's say 10 goes in there, 10 times 58. 10 is 2 times 5. 58 is even, so it's divisible by 2. So let's see, 58 divided by 2 is 29. And 29 is a prime number, so the only pair that I'm getting is this pair of 2's. So a pair of 2's will come out, and left over at the bottom of the branches is a 5 and a 29, so I'll multiply those. So h equals 2 times the square root of 5 times 29, which is 145. And that is in meters. Okay, and our last part here with the Pythagorean theorem is to determine what kind of triangle each set of side lengths would make, acute, right, or obtuse. Okay, so if a squared plus b squared is equal to c squared, it's going to be right. If a squared plus b squared is greater than c squared, it will be acute. If it's less than c squared, it will be obtuse. So here we have 5 squared plus 12 squared compared to 13 squared. Okay, so that's 25 plus 144, or we could just type in 5 squared plus 13 squared. Plus 12 squared. And we get 169. And 13 squared is also 169. So a squared plus b squared is equal to c squared, making this a right triangle. Okay, the square root of 8 squared plus 4 squared compared to 6 squared. The square root of 8 squared is 8. So it's 8 plus 16. And 8 plus 16 is 24. 6 squared is 36. A squared plus b squared is less than c squared. And that makes this triangle obtuse. Okay, then 20 squared plus 21 squared compared to 28 squared. 20 squared plus 21 squared is 841, and 28 squared is 784. So this time a squared plus b squared is greater than c squared, which makes this triangle acute. And last we have 15 squared plus 36 squared compared to 39 squared. 15 squared plus 36 squared is 1,521, and 39 squared is 1,521. A squared plus b squared is equal to c squared, so this triangle is right. Okay, so that is all for Pythagorean theorem. In the next video, we will review special right triangles.